Hello, today we are going to cover the topic graphing systems of inequalities in two variables. Let's consider this example. Graph the solution set of the system 2x plus y less than or equal to 6, x plus 3y less than or equal to 6, x is greater than or equal to 0, y greater than or equal to 0. So you can see that this system consists of four inequalities, and all these inequalities contain an equal sign. So we can call all these inequalities as non-strict inequalities. And let's graph the system. So for that, let's consider the first inequality, 2x plus y less than or equal to 6. So this inequality contains an equal sign, so the graph would be a solid line. So to graph this inequality, replace the inequality sign by an equal sign. So 2x plus y equals 6. So it is a linear equation in two variables. The graph is a line. So to graph this equation, we can use the method of considering the x-intercept and the y-intercept. So there are different methods to graph the linear equation. This is one of the methods. So to find the x-intercept, set y equals 0, so 2x equals 6. To get x, divide both sides by 2, so x equals 3, so the x-intercept is 3, 0. To find the y-intercept, set x equals 0, so this term becomes 0, y equals 6, so the y-intercept is 0, 6. We can use these 2 points to graph this equation, so we have to plot 3, 0 and 0, 6. So we'll get the graph of the equation 2x plus y equals 6 as this line. It's a solid line. And to graph the inequality, we have to consider a test point. So I'm going to consider a test point in the lower half plane of this graph. So for convenience, let's take 0, 0, substitute that point in the original inequality, 2x plus y less than or equal to 6. So when you substitute x and y as 0, so 0 plus 0, that is 0, 0 less than or equal to 6, that is true. So shade the half plane containing this point, 0, 0. So shade this portion of this graph, this half plane, okay, the lower half plane. And then let's consider the second inequality, x plus 3y less than or equal to 6. Again, solid line. And to graph this inequality, replace the inequality sign by an equal sign. So x plus 3y equals 6. To graph this, we can use the x-intercept and the y-intercept. To find the x-intercept, set y equals 0. So x equals 6. So the x-intercept is 6, 0. To find the y-intercept, set x equals 0. So 3y equals 6. Y equals, divide both sides by 3. So y equals 2. So the y-intercept is 0, 2. So to graph this equation, so we can plot 6, 0 and 0, 2. So 6, 0, this point, and 0, 2, graph this equation. And to find the solution set of this inequality, again, we need to consider a test point. Let's consider 0, 0 again as the test point and substitute in this inequality. So 0 plus 3 times 0, that is 0. 0 plus 0 is 0. 0 less than or equal to 6, that is true. So shade the half plane containing 0, 0. So shade this lower half plane of this graph. Okay. Now let's consider the third inequality, x greater than or equal to 0. So replace this inequality by an equal sign, x equals 0. You can say that this is the equation of the y-axis. So darken this is the y-axis, so darken this y-axis. And the inequality is x greater than or equal to 0. So all these points to the right of this y-axis. So shade this portion, okay? And you can see that, again, this is a solid line. The next inequality is y greater than or equal to 0. It's again a solid line, and replace the inequality by an equal sign, y equals 0. So we know that it's the equation of the x-axis. So y greater than 0, so darken this x-axis. Y greater than 0 means it is above the x-axis. It contains this point also, right? It's a solid line, so all the points above this x-axis, including this x-axis, right? And we have all these shaded regions, one portion, the first graph or this first graph, this is the shaded region is the lower half plane. Here it is this plane. And for the third inequality, this portion, and the fourth inequality, the portion above these x-axis, including these points too. So the intersection of all these shaded areas is this portion. So that is the solution set of the this system of inequalities in the intersection of all these shaded regions. So this is the solution set of the system is the intersection of all these shaded regions as shown in the graph.